Actually double checked it for a change. There it goes. Because I have off third period. So our test, y'all, hush. Our test is Monday. I can't remember exactly how many questions. Some of it's matching. Some of it's multiple choice. Huh? There's one on Monday over, it's not a lot of material. It's over the naming the acids and the bases. I have a bunch of stuff I'm going to pass back to y'all. It's over like the characteristics, how to calculate pH and molarity, molar concentration. Right in, stop. And then also predicting the, like, what's the other side of the reaction arrow look like. I think I still have people in here that did not do the previous test, the Unit 10 test. And I'm just, like I said, I just dumped a whole bunch of stuff into the grade book. I'm still working on it. I obviously have a couple here that were just turned in that are, they're not in. But let me shut the door and get us started. Go ahead. So the test will be Monday. No, don't do that. We've got a couple of harder things that we're going to be doing next week. These curves, enthalpy and calorimetry. I'm going to build a couple work days into next week. One after the second one's calorimetry. The first one is enthalpy. It's not that it's hard. It's just, it's a lot of stuff you need to do to get the right answer. You have to be able to do stuff like this on your test. Okay, these are all have the same parent element. Okay, they're all acids. I know they're all acids because they start with hydrogen. Okay, so the root word for this acid is going to come from which element then? Nitrogen. So it's going to have NITR, some way, shape, or form as part of the name. Okay, only one of these three gets a prefix hydro. Which one gets the prefix hydro? How do you know which one is the hydro acid? But what looking, no, the first one. Why do you know this is the hydro acid? Well, something that's got 3 hydrogens, there's no oxygen in it. Okay, so the nitrogen, which was originally the nitride ion, what does the I already know this is the one that's going to start with hydro. What does the I change to for nitrogen? Nitride becomes what? Oh, you will bomb this test if you cannot do your nomenclature. What does I changes to ic? So there's a couple of them that go back to the original elements named sulfur and phosphorus are like this. Nitrogen's not. So this is hydro. Now I've heard it pronounced both nitric and nitric. Why is it frozen? It's frozen. Let me go backwards. I had to adjust my screen because it was like all sticking off on the side with the projector. This is, once again, nitride. I becomes ic. This is the only one that gets the prefix hydro because there's no oxygen in it. Okay, so now these two aren't going to get hydros. How do you know which is the ite and which is the ate? Just by looking at them and not cheating. Y'all stop throwing things. And looking at the polyatomic ion chart. How do you know which one is the ite and which one is the ate? Just by looking at them. One's 2 and one's 3. So which is nitrite and which is nitrate? Yeah, the one that has more oxygens, in this case, is nitrate. That means that this is nitrite. And what does ite change to? No, changes to OUS. So this is nitrous or nitrous acid, because I've heard it pronounced both ways. And the ate becomes it. Remember, I taught you that the I ate it, it's icky. But then you need to know all your polyatomic ions to be able to go from that. So the way that azole does it is if it has 1, 2, 3, or 4 oxygens, or none. But there's all those exceptions. So you have to be able to do acid-base nomenclature. And that's part of what we're about to do today. All right, I had to animate this a little bit weird. Oh,
Maybe if you want to.
So those are the
What do you think?
Yeah, those are the answers to the opener. Those are the answers to today's opener. Like I said, with the exception of these couple that were just turned in, and this one that was just turned in, I've put everything else into the gray book, not the pH one, not this one. And I'm still, these are still coming in, and not the one from yesterday. But that unit 10 test, I never put in, so that's in, polarity's in. Both of the acid-base nomenclatures are in, and I'm trying to get caught up. Unfortunately, chemistry takes me a long time to grade. This is not something I can just look at or have Canvas grade for me. I have to pay attention to what you're doing to see if you're doing it right. Are we ready?
Not really.
I've been trying to open Canvas, but it wouldn't let me. It won't allow me.
Well, if it's a Wi-Fi thing, and I know that the bandwidth is not the best of the best. Let me check online. I don't see anybody else there. Uh-oh. Can you open that for him, Jared, please? I forgot he went to the potty.
Jared.
Unbelievable music going on there, Jared.
Jared,
Jared,
If you open the door, he just
just
like
open the door.
totally did not hear me.
Naughty, naughty.
check out an AirPod.
Find
out.
All right, y'all. We're gonna fill in the chart. This is the top part of this. No, shh. If you eat something that is acidic and it's safe to eat it, what is it going to taste like in general? Sour. Okay, this is what makes your cheeks pucker if you bite into a lemon or a lime. Or if you, well, some people like them.
Brandon built like a one.
And then if you bite into something that is a base, what is that gonna taste like? Bitter. Yeah, that's sort of like the response. No. If you've ever had your mouth washed out with soap, I don't know if parents still do that anymore, that reaction, that's to a bitter taste. What is the pH range of acids? From,
714.
no,
Seven.
one, okay, so it's below 7. Okay, remember, right at 7 is neutral. It's perfectly 1/2 acid and 1/2 base, which is water. So then what's the pH of the base? What's its range? Above 7. You know, the further, and I didn't like teach it this way because this is more of an IPC, like kidsy way to do it. 7 is safe. It is okay, I mean, unless it's poisonous, it's okay to drink things like water that are neutral. But the further you go away towards 1 and 14, or really 0 and 14, the more dangerous it becomes. And bases are just as dangerous as acids. If you put phenolphthalein in an acid, what's the color?
Yellow. Magenta.
Clear.
Oh.
Okay, and they say the word magenta, it really looks hot pink. So if you put phenolphthalein in a
It's not
base,
color.
well, absence of color, it is, it doesn't have a
It's not
color.
It is a color. This is
No, it's not.
Biologically, there is white, brown, black, and blue.
Yeah.
Well, and technically, everything you see is the color that it does not possess, because that's the way light works, but that's a physics thing. So, what is given off by all acids? What do all acids have in common?
One.
Which element?
Hydrogen.
Hydrogen. Now, hydronium, which they don't teach hydronium here. This is hydrogen ion. This is hydronium. This is actually how the hydrogen is carried. It attaches itself to a water, but it's an extra free floating hydrogen that has done that. So if you go off and take chemistry in college, they're probably going to have you use the hydronium ion, but it means the same thing. What do most bases share as a negative ion?
One.
Hydroxide. Your major exception is the ammonia base, the NH3. What color does litmus paper turn if it's in an acid?
Red.
Red. It really looks pink, but you say it's red. And then if you put that same piece of paper that's red into a base, it's gonna turn blue, like a very pale, I don't have any, sort of like this color, it's a pale blue. Now, other characteristics, I could put lots of stuff here. You need to understand that both strong acids and strong bases will burn you. Okay, you think of like Phantom of the Opera, you get acid on your face and it melts your face off. The bases don't quite do that, but if you get a base in your eye, and you don't flush it out immediately, it's probably gonna blind you. That's why it hurts when you get soap in your eye, because soaps are bases.
No, not really.
Stephanie, you first.
This is what we use as a subject.
Oh, efficiency.
Can you do what?
We need a test subject.
Yes, we do.
Test subjects. Okay. Does anybody still need this? There was a bunch of stuff that's on this chart. No? Okay. This is the way that Azel does nomenclature for acids. I just pulled it straight off of the notes that we did a few days ago. If it's binary, does not have oxygen. Those are your hydro roots, whatever it is, ic acid. Okay, so if it's fluorine, it would be hydrofluoric acid. It's just H and F. Okay, the root, this comes from the element that is not hydrogen. And in the case of tertiaries, the oxyacids, also not the oxygen. Now, you could do it this way, except there are exceptions. Okay, and the way that I do it, that I ate it, it's icky, and it's all right with us. Your polyatomic ion chart doesn't have every single polyatomic ion that's like in existence. It's the most common ones. So if, in general, you have one oxygen, these are your hypo root us acids, because these are both ites. Okay, these are both eights. Okay, now, not every one of them has a hypo and a per. Chlorine does. Iodine does. The chlorine acids, there are 5 different chlorine acids. There's hydrochloric, there is hypochlorous, there is chlorus, there is chloric, and there is perchloric acid. It's the only one that has all 5. Well, at least the common one that has all 5. I don't make acid nomenclature. This is the way that it's, I don't really like to do it this way. But I know how to name them. In general, if you have 2 oxygens, there is not a prefix. It's going to be the root, so like sulfur, phosphorus, but it's going to end in OUS. And this is also an ite. It's like been watching you use your phone and just like cheat like crazy right in front of you. You're looking at other people's worksheets and putting them on the. You really think I'm blind? I need to get out of my room. Just come out. Step out. So many bad words are going to come out of my mouth right now. If you have 3 oxygens, okay, in general, this is an 8. Okay, it doesn't get a prefix, so it would be like phosphoric acid or sulfuric acid or nitric acid. And if there's 4 oxygens, which there's not very many of these, but this is where we have exceptions. This is your per whatever ic acid. Okay, so the 8 to ic and the ite to OUS, that always works. These would have already been on the polyatomic ion chart as part of its name, which is why I like to do it my way. It's just like I said, that polyatomic ion chart doesn't have every single polyatomic ion like listed. Okay, so the way that I showed you how to do this, which is not, I don't think this is on yours, but you can put this down underneath it, was if it's an 8 poly, it changes to ic. Okay, and if it's an ite poly, it changes to OUS. This does not fail because on the polyatomic ion chart, let me show you, and I linked this in Canvas, they already have hypo. They already have per on there. Like, that's part of their name, so you don't have to worry about that. And then I don't have a stupid way to remember the ides. It's just no oxygen is the hydro-ids. I don't have a dumb way to remember that. So I don't care which way you do it. I will let you use this on your test. All right, naming. You can do this two ways. You can either do their rule, and their rule was if it had two oxygens, it's root us acid, which this does work. But you can also look this up on the poly chart, and this is chlorite, and ite becomes us. So this is chlor us acid. Now this is a base. So what is Li? Which element's Li? And what is OH?
Oxide.
No, that's hydroxide. I heard oxide. Hydroxide. So you don't need Roman numerals with lithium. It's just lithium hydroxide. Most bases do have OH at the end. Okay, the next one has no oxygen, so this is a hydroic, hydrofluoric acid. 4 oxygen. Now you're not going to see this on your polyatomic ion chart, but 4 acids is a per. Oh, so much.
You want that?
No, you.
Not slow.
Okay, now the next one, that's 4 acids. The exceptions to the 4 acids having per are the phosphorus and the sulfur ones that have 4, because that's just phosphate and sulfate. This is not one of them. So this is per brome ic acid. There are 2 exceptions to this per having 4. It is the PO4 negative 3 and the SO4 negative 2. That is just phosphate and sulfate. So they don't get a per. But this is not on that chart, so this is going to follow that rule. So 4 oxygen is per bromine, because, this is really bromate, becomes bromic acid. Now, there's a lot of nomenclature on this test. Now, this is a base, which element's Ba, and this is hydroxide, barium hydroxide. You also need to be able to tell if it's an acid, a base, or a salt just by looking at it. And we'll do that here in a second too.
I'm not that smart, though.
It's,
I think we do that maybe.
like I said, because we all eat lunch together, all the chemistry people, we want to push this back where it belongs when we do ionic and covalent compounds. Because that's really where it should be. It's just the people who have never taught chemistry that are telling us what to do in the whatever dumb order they changed it to this year. That's what they told us to do. And we kept trying to explain to them, this needs to be in the nomenclature unit. This does not need to be when we're doing pH. But they won't listen to us. So all that stuff that you did before is no longer in your brain, and you need to be able to use it. HiO3, this is iodine. So this is an ic acid. This is the one we have to sort of watch how you pronounce this. It does not get a hydro. So iodate becomes iodic acid. So iodic acid. I'm not saying that word.
I think I'll heard about this.
Second.
You shut your mouth.
Okay.
How about they do now?
Seven.
Let her talk.
I told you guys keep talking about Lake Titicaca in my ESS class. And they keep laughing, and I'm like, I didn't name the lake. It's real, and it's in Peru.
It's like the
It's the highest elevation lake. I didn't put a picture of it on the thing. Baikal Lake is beautiful. That's the deepest lake. It's in Russia. It's over a mile deep. Okay, this is the sulfate ion. Okay, so sulfate goes all the way back to sulfuric acid, or I'm sorry, this is sulfurous acid. This is sulfite, not sulfate. This is one of the exceptions to the rule. And then this is a wait. One is hypo, so this is hypochlorite, this is hypochlorous, no, ite is us, acid. So you have to be able to do acids and bases. You have to be able to predict products.
This is a lot of.
Huh?
This is a lot of acid.
It's what this unit is. It's
Why do we
acids
make
and
all the
bases.
acids
It's-
together?
It'll blow up.
These zombies gonna come to life.
Can we blow some stuff in this car?
No, we do not blow stuff up in the class.
Why not?
Do you really think we would let you guys make things explode on purpose?
Yes.
As long as we were up front.
Isn't that what chemistry is?
No.
That's what,
Can we shoot bottle rockets in this class?
No. What? No.
You
Yeah,
ever done
shoot
that?
bottle rockets. Actually, yes, we used to shoot and Roman candles at each other. when we
That's
were
what
younger,
you-
And I actually had a Roman candle impale itself into my side.
Mm.
Yeah,
I
that-
kind of blow up my hand. I swear to God. Someone can't really do it with my hand. Oh,
the last time we set them off, my dog at the time, because you stick them in the ground and they shoot.
Don't tell
The
me
dog picked it up in his mouth when it was going and was running around and it was shooting flaming Roman cannonballs out the other end at people.
I swear to God, I saw a dog like that, bro. It was either a TikTok or something, but I swear to God, I saw a video like that.
I didn't hear it wasn't my dog because that was a long time ago and
It was like a bug.
we had cell phones, but they didn't have like the camera capability. It was just texting way back when, 20 something years ago. That dog's so dumb. It was funny though. All right, formulas for the following. What?
Me and my brothers go back get a bottle rocket. We get cut it, get stuck it in a bottle. At the same time, this dude came riding on a spoiler. And this dude would have waited a little bit longer. We got pegged inside the head with the bottle rocket.
It's not good.
And it's kind of funny because it literally missed him by.
It can be very dangerous.
He didn't realize because it went like.
I also had a sparkler extinguished in my side. My sister's just regular sparkler. She got all excited. She was like 6 and she turned around and right into my side.
How did it drop?
It hurt. It's not, okay, whoever said go back, are you ready?
You're so fire happy on my.
Okay. Ammonia is just one that you need to know. Okay, ammonia is a very strong base. Its formula is capital N, capital H, 3. Copper, 2, hydroxide. What is copper's symbol? Cu. What is its charge? 2. Okay, hydroxide is OH, and it carries a -1. So what would the formula be for copper 2 hydroxide? Yeah, the OH goes in parentheses, and the 2 goes outside. This right here is why we really needed to do this when we were doing ionics and covalence. Because when they don't add to 0, you switch them. Per iodic acid. Per means how many oxygens?
4.
Okay. Iodic comes from iodine. Okay, we obviously are starting with hydrogen, so it would be HiO4. That is an I, that is not an L. It's just the font that Google Slides defaults to, that's what they're capitalizing. Oh, it's not. I'm running on 2 hours of sleep.
I said I know it's an I.
I said it was an L.
At first I did, then I changed it to an I, and then you said no.
Oh, it's an I.
So just no, guys. I'm just kidding.
Are there
She said that
questions?
Is it your
Mhm.
observation?
Mhm. All right. Next bit. being able to go between molar concentration, how strong is the acid or the base, which is the one with the M, or the pH or the pOH. What's the magic number that we're trying to get to? Either this number or this power. I know this is negative and this is positive. What's the magic number? What's the highest pH can go? 14. So the magic number is 14. These, like if I know my hydrogen ion concentration, now you can do this with the logarithm button on your calculator or just understand the relationship. What's the pH according to this power? 3. When you take the logarithm of 0.001, which is what this translates to, it tells you, now you got to take the negative of that log. It tells you that the pH is 3. If I then ask you what the potential for hydroxide is, then it would be 14 minus 3, which is 11. And because, now, to figure out if it's an acid or a base, you look at the pH level, not the pOH level. 3 is below 7. Whatever the heck this substance is, it is acidic. And like I say, the closer you get to 0, the more dangerous this thing is going to be. So something like battery acid, you get that on you, and it's going to start hurting really, 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 really quick. Not like make your skin melt off like the Indiana Jones movie. Not quite like that. But if you don't take sulfuric acid off of you, it's going to start turning red, and it's not good. Coca-Cola is acidic too. It'll eat nails. If you leave a nail in Coke, I don't know about that Coke, but regular Coke, it'll eat the nail because it's corrosive.
Like the actual nail?
Yeah, like a hammer nail, not a fingernail,
Oh.
metal nail. Okay, now hydroxide
Wait,
concentration.
is that why like you put rusty like food or whatever in Coke?
That's why people do that.
Yeah, they also put Coke into toast.
Yep.
And why do people drink it?
I don't know. It's one of the worst ones for
You
you.
know what it is?
It literally is-
Okay, so your
Yeah.
your hydroxide ion concentration. Now this is not pH. pOH would be what?
No.
This is no. My pOH would be what? No, not negative, just 5. My pH, however, would be what?
No.
9, because that's the difference from 14. So my potential for hydrogen is 5, or not hydrogen, for hydroxide is 5. You subtract that from 14, and your pH would be 9. This is a base. Now, my hydrogen ion concentration then would be 1 times 10 to the negative 9th molar concentration. Most of you, when I was grading, because I'm still grading the paper that was over this, you did just fine. Well, some of you were telling me it was an acid and it was a base, but other than that, numerically, most of you did okay. If you got a specific one wrong, I'll put an X on it. I have not graded the ones that are in Canvas if you uploaded them that way.
So, are we just like,
What's me? You can do it. What?
subtracting?
Yeah, you're the difference is 14.
I'm sorry, I'm not.
Whether it's a positive whole number like this or it's a negative power, the magic number is 14. So if my potential for hydroxide is 11, what's my pH?
Good.
3. And this is below 7, so this is an acid. Man, you're just adding and subtracting to get to 14. That's it. Now, so that means that my hydrogen ion concentration would be 1 times 10 to the negative 3rd. I said most of you did okay with this. Hydrogen ion concentration is 1e negative 7. What's the pH? 7. The pOH would be 7. And this is the neutral compound on the page.
So it's a pH, however far it is away.
Oh my God.
And then I am going to add one more thing on here that's not on your review
Yes,
because
sir, can we have 15 minutes?
It's okay.
Jesus.
Are there any other questions about this? Because this really, mathematically, this is really not that hard.
Yeah.
Because they're keeping your pHs and your exponents as whole numbers. If you have decimals, it makes this way harder. They don't do that here. Very nice. Yes. Predicting products. We have an acid and a base reacting with each other. Okay, the acids are going to be starting with hydrogen. Okay, bases normally do have hydroxide at the back of them. I know ammonia is different, NH3. Now, when you mix an acid and a base, they make two things. They make something called a salt, which is going to be the metal first from the base with the thing that is not hydrogen from the acid. And the other thing that they make is water. Now, I'm going to write water a different way. I understand it's H2O. Okay, but for balancing purposes, and if you take organic chemistry or biochemistry, they are going to very strongly, in fact, you're going to have to write water as HOH. Because that's the way it does its thing. So I think they're all balanced for you already. Well, at least on the test. The test is not asking you to balance. But I have one sodium on both sides. I have a hydroxide and I have a hydroxide. I have a hydrogen and I have a lone hydrogen. And then I have the periodate here, and that's periodate there. So everything's balanced. I didn't put ones on here. You can put ones as coefficients if you want to. But you do need to be able to understand that this is a base, this is an acid, this is a salt, and this is water. I'm just writing it differently on purpose. You want the technical name for water? I mean, we call it water. It's dihydrogen monoxide. Is the scientific name.
That's what he was asking.
Okay. So even though I accidentally put the next one up here, this is my acid and this is my base. The lithium is going to go with the sulfate, and the hydrogen is going to go with the hydroxide to make water. Lithium is +1, sulfate's -2. Don't crisscross it. So I needed 2 positive ones for every 1 -2. So that's why the formula for lithium sulfate is Li2SO4. This is my salt, and then this is water. Now this is not balanced. I've got, no, they're already done, but because this was part of your most recent assignment, I'm going back over it again. So I need 2 to balance the 2 lithiums. I now have 2 hydroxides. So I need 2 hydroxides, and now everything's balanced, and so my missing numbers are ones. The last one, this is my base, this is my acid. The aluminum is going to combine with the sulfur. Aluminum is +3 and sulfur's -2, so we're going to flip-flop them. And then the other thing is water. Like I said, I am writing it this way just to make it easier to balance. So 1, 2, this is going to fix my aluminum on the left. 2 times 3 is 6. I need to put a 6 here to fix the hydroxide. 3, 1. I'm going to put a 3 here to fix the sulfur. 3 times 2 is 6. I need to put a 2 here to, oh, that should be a 2. No. 3 times 2 is 6. 1 times 6 is, oh, shoot. I forget that my board is smart again when I touch it too hard.
Smart again.
Well, I mean, there was a point when it was just not registering, and I still can't write on the screen at all.
Have you tried with it?
No, but it makes me so angry I want to punch it, and I don't want to break school property.
Do it in the eye.
No.
Worst case scenario, you said that you fell.
Into the board with my fist.
Worst case scenario, bring that girl.
One last thing, it's not on your paper. You do need to be able to identify common household acids and bases. Vinegar. Vinegar is a very common acid. baking soda, if you ever get a bee sting, that's the white stuff that they put on you to pull the paint out and the stinger. That's a base. You make a baking soda water slurry and then you put it on where you got stung, and when it dries up, it pulls the stinger right out and it pulls the venom with it. You didn't know that? Okay.
So every time I was stung by a bee, instead of me being taken to a hospital because I'm dying.
Are you
I
allergic? You
never
get, well, that's different. If you have an EpiPen then for it,
That's why you can't just do that.
well, some
I was
people
at
are.
football practice one day, and I was gonna take off,
I'm allergic to it,
last
but
year.
I'm
I was at football practice, I was gonna do a chin
I
strap,
don't know.
and there was a bee on my chin strap up here, and I squeezed that bee, Lee said, it stung me, my thumb was literally the size of a freaking.
Yeah, there was a wasp nest in the